Now let us take up piecewise defined functions, in which the function is defined by a different expression in various parts of the real line or in the various parts of its domain. So for example, say we have a function here that it is defined by 2x minus 3 for values of x less than 2, and then at 2 and afterwards it's defined by another expression. As you can see, the slope has become lesser. So in this case, say you have to find the value of f at 0, what you would notice is this, that is 0 is less than 2. So the output would be given by this expression. So that is, you will take 2 times 0 minus 3, that is the value of the function would be negative 3. And then say you have to write the value of the function at 2. Then notice this, that when x equals 2, it is defined by x minus 1. So that will be 2 minus 1, that is 1. And then say you want the value of f at 5. Okay, then what you will have is 5 is more than 2, so you will use this expression here. So that would be 5 minus 1, that is 4. Now let's go ahead and graph the function. I computed value of an extra value here for you, that if you take x equals 1, the value will be 2 times 1 minus 3, that is negative 1. So anyways, going for, so what the function is, it's negative 3 at 0, and it is negative 1 at 1, okay, and at 2 it is 1, right, and then at 5 we just went straight to 5, and that's what I took this as. It is 4. So our graph would be, so we'll just make a straight line here, right? So here is a graph for x values 2 and below, and then for actually below 2, and from 2 and afterwards here. And here is just like, in this case it is a continuous function, but it may not be continuous, and you will see such cases later. So here the function is graphed by this line, and here it's graphed by the other line, which has a smaller slope and just a little point to note.